Hello. Today we are going to talk about the WebRTC Application Controller, or WAC, and how this element is managing all the complexity in a real field deployment of a WebRTC service. Here in this slide, you can see the role of the WAC. Here we have an element that is going to be the web server, so it's the element that is managing or is hosting all the different WebRTC applications. But as you can see here, we have a lot of connectors with other elements, and these connectors have been designed to manage part of the complexity of a WebRTC deployment. So today we are going to move to the next slide, and we are going to talk about 6 points that we should take into account when we plan to make a rollout of a WebRTC service. First is to try to deal with the browser complexity. Now, we found that the different versions of Google Chrome, Firefox, Opera are implementing, well, for sure they are implementing the WebRTC API that has been defined by the W3G, but they have different flavors depending on the version, depending on the device. So the same application is not going to work the same way in a browser with a specific version or in another browser with other version or running in a different type of device. So this is something that we try to solve with the WAC. When you are making an HTTP request to the WAC, we are going to detect which is the version, which is the browser that you are using, and we are going to adapt the JavaScript code to this version. In addition, we have the Internet Explorer that is implementing is going to implement a different version of WebRTC called ORTC. And this is something that we are going to extract also in the WAC. So as soon as this capability is available in the Internet Explorer, we are going to detect that you are using Internet Explorer. We are going to adapt the code of the application to make this WebRTC application works in your browsers. And for sure, we are going to take into account the next version, probably a future WebRTC API 2.0 or something like that. Well, something that we are also waiting is for Safari, the browser from Apple, that today is not supporting WebRTC and that they not have any public announcement. But we are implementing, we are supporting also for the Internet Explorer some open source plugins that brings WebRTC capability to this type of browser. So when you are using Internet Explorer or Safari, we are going to ask you to install a plugin to make to support WebRTC, and we can adapt the applications to work with your plugin. The second point is device complexity. Here the problem is that, I have introduced part of the problem, but it's more important when we are talking about smartphones. In the case of smartphones, we need today a different approach to the use of a browser, because with the browser we don't have the possibility to connect to the notification engine of the device. This forces to have the browser open to receive a call, and in terms of battery consumption, so it's critical. So the approach that we are following is to use the Cordova framework from Apache to adapt the same code, the same WebRTC application to a native or hybrid application for Android or iOS, with the ability to connect with the notification engine of the device, and also to bring new functionalities that are not possible from a browser, like to have access to the contact list or agenda of the device. In addition, well, as we are detecting the type of device, we have the ability to make a responsive design and to adapt the appearance of the WebRTC application to the type of device or the type of screen. The third point is about interconnection. We have some collaterals on this, because we have a lot of complexity here, but the most important is to have the ability to manage everything around users, like authentication, provisioning, privilege, policies, accounting. The idea is to have different connectors that can bring the possibility to the WAC to manage authentication with existing elements on IMS, on NDN network, and also to offer something that we call the service API. That is a client and server mode API that helps to manage the authorization, billing for integrators of OSS and BSS, and also to deal with different authentications problems from the WebRTC gateway. So today we have some of these connectors available. We have this API already defined with some methods available, and this is what make the WAC the best element to manage all you need when you are planning a real WebRTC deployment. The fourth point is manage the scalability and availability. Here the problem starts when we are managing more than probably 100 or 1,000 concurrent calls. The idea is we need some elements to manage or to balance the HTTP requests. Here we are using a third-party HTTP load balancer. And also the WAC provides some elements to balance the access to the gateways. It's something that I didn't mention before, but the WAC is a web server. You always need a WebRTC gateway when you need to connect with an existing network. And we have added in the WAC some elements to manage the scalability or the access to different gateways from a specific WebRTC application. The fifth point is about security. In WebRTC, we inherit all the problems regarding VoIP attacks, and so also we have all the problems of the web wall, and we have some new WebRTC attacks. The WebRTC gateway is going to manage part of these attacks. For sure, we can have also a SDC or something like that to deal with security in concurrent calls, but in the WAC, the web server, we need to add some mechanisms, and it's something that we do here to manage this type of attacks. So we have some elements to manage authentication, to try to avoid denial of service or distribute denial of service attacks, and so. So if you want to learn more about security, I strongly recommend you to download a white paper that's available in our website about WebRTC security concerns, and take into account that the WAC is the right element to the Sippo WAC is the right element to try to manage, to try to avoid this type of threats that are possible in a WebRTC service. And finally, this last point that I'm going to mention today is about signaling. As you probably know, WebRTC does not state anything about signaling. Some different gateways, different vendors are implementing different protocols. We know a lot of these problems because we are authors of some of the traditional or typical signaling protocols that are being used by different vendors today. And the idea here is that the WAC detects which is the gateway that you are going to use, and depending on the gateway, adapts the code of the WebRTC application to the signaling protocol that is implemented in the gateway. So we have the ability to just code once and adapt the code, the JavaScript code that you're going to download to the different signaling protocols that these vendors are using today. So this is great when you you are a developer and you want to create an application that can work with in any ecosystem. The WAC is going to make this possible. And also it's great for those telcos that have different gateways in their network with WebRTC capabilities, and they want to test or they want to try or make these applications work with all these different WebRTC gateways. So that's the sixth problem, internal complexity, that the WAC is already solving, and this is something that is shown in this slide that we are using for this, the Sippo abstraction layer, that is the element that is hiding all this complexity, the complexity of browsers, devices, the complexity behind the different implementations by vendors, and all the tools that you need to make this WebRTC service work in your network. So that's all for today, and see you in the next video.